Back in 1832, Nikolaus August Otto was born on June 10 in Holthausen in der Heide, Germany. He was the youngest of 6 children. Unfortunately, his father died the same year he born, but life goes on and he began school in 1838. After 6 years of good performance, he moved to the high school in Langenschwalbach until 1848. He did not complete his studies but was cited for good performance. His main interest in school had been in science and technology, but he graduated after 3 years as a business apprentice in a small merchandise company. After completing his apprenticeship, he moved to Frankfurt, where he worked for Philip Jacob Lindheimer as a salesman of colonial goods and agricultural products. Otto worked for various companies, first for I.C. Alpeter and then in 1860 for Karl Mertens. He traveled throughout Western Germany and sold colonial goods, coffee, tea, rice, and sugar. After some time, he decided to quit his job and pursue his passion. In late autumn of 1860, Otto and his brother learned of a novel gas engine that Jean-Joseph Etienne Lenoir had built in Paris. The brothers built a copy of the Lenoir engine and applied for a patent in January 1861 for a liquid-fueled engine based on the Lenoir engine with the Prussian Ministry of Commerce, but it was rejected. Otto was aware of the concept of compressed fuel charge and tried to make an engine using this principle in 1861. It ran for just a few minutes before breaking. Otto's brother gave up on the concept, resulting in Otto looking for help elsewhere. From 1862 to 1863, Otto experimented with the help of Cologne mechanic Michael J. Azans in an effort to improve the engine. Running low on funds, in 1862 Otto worked for Karl Mertens again in order to continue work on his engine. Early in 1864, Otto sought investors to fund his research. He found Eugen Langen, whose father was a sugar industrialist. Together they entered into a partnership on March 31, 1864 and named it NA Otto & C in Cologne. This was the world's first company focused entirely on the design and production of internal combustion engines. For all its commercial success, with the company producing 634 engines a year by 1875, the Otto and Langen engine had hit a technical dead end. It produced only 3 horsepower, yet required 10 to 13 foot headroom to operate. Otto turned his attention to the 4-stroke cycle, at which he had failed in 1862. Largely due to the efforts of Franz Rings and Hermann Schumm, who were brought into the company by Gottlieb Daimler, Otto succeeded in making the 4-stroke compressed charge engine and named it the Otto Silent engine. This was the first commercially successful engine to use in-cylinder compression. The Ring-Schumm engine appeared in autumn 1876 and was immediately successful. Otto married a woman named Anna Gassi, and the couple had 7 recorded children. His son Gustav Otto grew up to become an aircraft builder. Gasoline and air mixed together form an explosive mixture. The basic job of the engine is to convert this explosive energy into motion. To contain the explosion, the engine uses a cylinder. And fitting snugly within the cylinder, a piston that slides up and down. Inside the cylinder, an electric spark ignites the compressed gasoline and air, and the hot gases from the explosion push the piston downward. The piston rod is connected to a crankshaft which converts the up and down motion into rotary motion. The crankshaft then drives the rear wheels through various machinery which we'll see later. Here is a different perspective on how the piston drives the crankshaft through the connecting rod. At the top of the cylinder of the valves which let in the gasoline and air mixture. For increased power and smoothness, modern auto engines have a number of cylinders driving one crankshaft. Gasoline from the tank is pumped by the fuel pump to the engine's carburetor, through the fuel lines. The carburetor mixes the gasoline with air to form the explosive mixture that drives the pistons. Here's a closer view of the carburetor. A linkage connects the accelerator pedal with a valve in the carburetor. Stepping on the gas opens this valve wider, increasing the gas flow and speeding up the engine. Easing off on the pedal reduces the flow and the engine slows down. Here on an actual engine of the counterparts of the fuel system just diagrammed. The fuel pump. The fuel line from pump to carburetor. And the carburetor itself, whether its air cleaner removed. Here is the linkage connecting the carburetor to the accelerator pedal. The engine's electrical system supplies the spark that fires the fuel mixture. As the engine rotates, it drives a generator which keeps the car's battery charged. The battery supplies electricity to the coil, which boosts the current to a voltage high enough to produce a spark, and then sends it through the distributor to the spark plugs located in the cylinders. The distributor distributes electrical current to the proper spark plug of the proper time. Inside the distributor is a rotor, which as it turns touches a series of contacts, one of which is wired to each spark plug. The points open and closes the rotor turns, interrupting the current to produce the fuel igniting spark. Here again are the major parts of the engine's electrical system: the generator, the battery, the booster coil, distributor, and spark plugs. Now looking at an actual engine, here is the generator and the battery, together at the rear of the engine of the coil. The distributor cap containing the contact swept by the rotor. The rotor itself and the points, which sometimes need adjustments. And finally in the cylinder heads the spark plugs. The engine on this model chassis contains nearly all the parts found in a working engine. Let's break it down to its fundamentals and then build it up again. Here's the heart of the engine: the cylinders and pistons. This engine, known as a V8, has two banks of 4 cylinders, each driving a common crankshaft. The camshaft geared to the crankshaft lifts and lowers the valves and the cylinders. Now the right and left cylinder heads containing the valves themselves and the valve lifters. The distributor at the rear of the engine is also driven from the camshaft. Now the fan, the generator, and a part of the cooling system. Here, flashing lights simulate the firing of the spark plugs as the rotor supplies current to each and proper firing order. Continuing the build-up, here are the carburetor in the manifold. And finally, the air cleaner atop the carburetor. Here is a rear view showing how the pistons drive the crankshaft. And down through the plastic housing we can see the gearing connecting the camshaft to the distributor. 4, 6, and 8-cylinder engines are standard today. This V8 configuration is very popular for its smoothness and power.